For this one, we're going to compute right endpoint Riemann sums instead of left endpoint for f of x using 4 subintervals on the interval from -2 to 2. So first of all, anytime we read that we have a Riemann sum to me means I need to start by finding delta x, b minus a over n. So it's going to be, for this one, we have a to b, so b is 2, minus a is -2, over n, the number of subintervals. This is 4 equal subintervals, so n is 4. So we're going to divide that by 4. So we have 2 minus -2, which is going to be 2 plus 2, which is 4, over 4. Our width is 1 again, just to make it easy on us to have to draw it. So we're going to draw boxes with a width of 1. 4 subintervals means we're going to be drawing 4 boxes this time. We're going to start at our lower endpoint, so we're going to start down at -2 in the x value, and we need to draw something that has a width of 1, which tells me we're going to go from -2 to -1. Now I'm using right endpoint Riemann sums. So I need to be on the right side. So I don't want to use the y value for -2. I want to use the y value that corresponds to -1. So I'm going to follow this line that goes up until I hit the graph on the right-hand side. All right, and that whole box is going to have the height of the right-hand side. So there's my first box from -2 to -1. And so our width of that is going to be our width times our height. So our width is 1 and our height is 5. So this has an area of 5. We have a good start to our right Riemann sum. Our first box is having an area of 5. Now we're ready to draw our second box from -1 to 0 because it has to have a width of 1. And then I need to use the y value at 0. I'm going to go all the way up to 6. There's the whole box is going to have a height of 6. So height is 6 times width is 1. This has an area of 6. I'm not done until I've drawn 4 boxes. So my next box is from 0 to 1. And again, I'm using the right-hand height. So I'm going to use the height at 1, which is 5 for the whole box. So 5, my height times my width is 1 is just going to give me 5. And then lastly, a box from 1 to 2. And I'm going to use the height on the right-hand side. So I'm going to use 2's y value to give me the height of the box, which looks like it's at 2. So 2 times 1 is just going to give me 2 for the area. So my right-hand Riemann sum with 4 boxes, we can call R or S, or another way to denote it is R sub 4. However you want to denote it. Right Riemann sum with 4 subintervals. 5 plus 5 is 10, plus 6 plus 2 is going to give me 18 for my right Riemann sum. So of course it's not perfect. If I'm looking at this picture, this is way overestimating. This isn't even under the curve. Neither is this, but then this is under the curve and we missed it with our box, as well as this. So not a perfect answer by any means. So the question is, how do we find the most accurate area under the curve? And our answer is not whether it's a left or a right, it's to make n large. That number of subintervals large. Lots of subintervals. If we had done that with 8 subintervals instead of 4 even, our answer would have been much closer. We wouldn't have had so many pieces to color saying, hey, we missed some or we did too many. Just having 8 compared to 4 would have been a better answer. So the more subintervals, the better. So that crazy formula for Riemann sum, the crazy Riemann sum formula makes sense. So now that we've done it a couple times, we know what each piece means. The reason why we had the limit as n goes to infinity is because we want many subintervals. That's what that first part indicates. many subintervals, we add them all up. So that's why we have that sigma. We're going to add up. We didn't subtract areas, we added them together. And then what we were adding up, the next part of this formula was x sub I star, and then it was delta x. And that's because we had the height times the width, delta x. So between that first and the second example we did, I would say that it wasn't a difference between left and right, it was the difference in the number of subintervals that made our answer better or not, comparing the two.